Hello everyone, so welcome to my YouTube channel. So guys, yes, what are you waiting for? Yes, I know what are you waiting for. So guys, we are going to start CET crash course for chemistry subject for 2026. So first of all, where you will get this? Go to my channel, go to the playlist. In playlist you will get a CET course. Okay, so you will click that playlist, you will get this. So it will start from video 1, video 2, video 3, video 4, like that. So guys, in this what we are going to cover, the main important thing. Yes, so in this we are going to cover whole chapter A to Z for chemistry, whole chapter for chemistry for CET, only for the concept for CET. Means what they, so see here, understand which topic we are not going to touch, means which is not in the CET syllabus. Okay, which topic we are going to do, which is in the CET syllabus, nothing more, nothing less, exactly based upon the CET syllabus. Okay, so total in chemistry, class 11, class 12, whatever the chapters which is in the syllabus for the CET, we are going to cover each and everything based upon the last 20 years question, based upon the last 20-year questions. So we are going to solve here 20-year questions. Okay, from 2005 to 2025, which is much enough. So what will happen if you will follow this? So easily I can assure that in chemistry, out of 60 you will score 50, minimum of 15 Kcet you are going to score. So guys, stick to this channel, subscribe it, and then press the bell icon, so whenever I will upload this video you can get the notification. Okay, and share the link to your friend, let them to join and do a crash course, and easily all will score 50 out of 60 in chemistry Kcet. Okay, so let's guys start the thing. The first chapter, see, first we will start for class 11th, whole whatever the chapter is coming for the Kcet chemistry, then we will start for the class 12th. Okay, so guys, how we are going to do first video for every chapter, like suppose this is some basic concept of chemistry. So today the first video for some basic concept of chemistry, I am going to explain only the theory parts, formula parts, important tricks, these all the things I am going to explain the concept. Okay, then next video, the video 2, which will be of some basic concept of chemistry, in that video we will do the PYQs plus hot questions. Okay, and PYQ consists of last 20 years. Okay, so next, suppose video 1 done, video 2 done, video 3 will start the chapter number 2, that is structure of atom. So video 3 will be only concept. Okay, the theory, formula, important tricks, that concept. Then video 4, which is the second video for structure of atom, in that we will do the PYQ plus hot for the structure of atom. So what will happen, it will be easy for you to do. It's not like a, if you will do in one video only, we'll do the concept also and then a PYQ plus hot question, to the video length will be more, 2.5 hour, 2 hour 40 minutes, 3 hour, 3.5 hour, like that it will go. So it will become a burden for you to do a 3 hours of video, 2.5 hours of video. So what I am going to do, first concept, second video PYQs plus hot questions. So it will be like less time, 50 minutes, 55 minutes, 40 minutes, 1 hour. So it will be easy for you to complete. Okay, chalo here, and it will become easy also. First you will understand all the concept and all, then you will jump for the PYQs plus hot questions. Okay guys, so we are going to start with some basic concept of chemistry. So guys, just stick to my notes, nothing more, nothing less. Stick to the notes, stick to the PYQs and hot questions. What I am going to do, that's enough. 50 marks is yours, chemistry Kcet. Okay guys, and don't forget to like it, subscribe and share to your friend. So we are going to start with some basic concept of chemistry. Okay, so guys, what we are going to learn in this chapter, so the topic which is coming in this chapter is interconversion of temperature. Wait, I'll change the color. Some basic concept of chemistry, Kcet. So guys, one question they will ask in the examination or 2 questions. You can expect 2 questions in the examination. Okay, or very less, so 1 question definitely they are going to ask. And if you're this is very good, means 3 questions they will ask, which is very rare. So 2 questions or 1 question, so definitely they will ask. Okay, so these are the topics what we have to study for the some basic concept of chemistry only for the CET. Don't start reading from the NEET for this NEET or JEE, no, only for the CET. So first we'll see the interconversion of temperature, next significant figure, third law of chemical combination, Dalton's atomic theory, atomic and molecular masses, mole concept, percentage composition, concentration terms, then PYQs plus hot questions. So these are the topics we are going to cover up. Okay, so PYQs and hots will be in next video. So today we are going to cover up this whole concept. Okay, fine. So first topic is interconversion of temperature. Interconversion of temperature means very easy. So either they will give you Celsius, means degree Celsius, you have to find the Kelvin, or they will give you Kelvin, you have to find the degree Celsius, or they will give the degree Fahrenheit, you have to find the degree Celsius, or they will give the degree Celsius, you have to find the degree Fahrenheit. This is interconversion of temperature. So four formula are there, just we have to see how you are going to use which formula you are going to apply. Very simple thing is very important. We have to first see, don't start by hearting. We have to understand that which formula we are going to use when. Okay, which formula we are going to use when. So here in interconversion of temperature we have a four formula. So how we will get to know which formula we have to use when? So guys, just we have to see the two things. First is which temperature is given, second which temperature we have to find. That's it. If suppose Fahrenheit is given and degree Celsius we have to find. So what? See, Fahrenheit is given and degree Celsius, so no, here no Fahrenheit, here no Fahrenheit, here yes Fahrenheit, here also Fahrenheit, but here we have to find Fahrenheit. No, here Fahrenheit is given and we have to find degree Celsius, means we are going to use this formula. This formula will not use because here we have to find degree Fahrenheit, but here in the question they told to find degree Celsius. Fahrenheit is given, so in this Fahrenheit is given, you have to find the degree Celsius. So this is the thing how we will get to know which formula we are going to use. Okay, now see, this is the thing guys, many students will get confused here, either you use plus or minus. So I will tell you a very short and easy trick. See, if you are going, if Celsius is given, we have to find Kelvin. Okay, if degree Celsius is given, we have to find Kelvin, means what is happening? Oh bolo bhaiya, what is happening? If degree Celsius is given, we have to find the degree Kelvin, means we are moving forward, right, from C to K. Correct, degree Celsius is given means C and we have to find degree Kelvin means K. So we are moving forward in alphabetical order, C to K. C to K means C is given, we have to find K. Correct, we are moving, we have C, we are moving to K. So means we are moving forward. If we are moving forward in alphabetical order, what will happen? Plus 273.15. Value will remain same, 273.15. Same reverse. If degree Kelvin is given, we have to find degree Celsius. So where we are going? We are going to degree Celsius. So from K to C. K to C means back in alphabetical order. So back means minus 273.5. That's it. Okay. If degree Celsius is given, we have to find the degree Kelvin, means what? C is given, we have to find K. We are moving forward. So forward means plus 273.15. So for finding the degree Kelvin, formula is K is equal to degree Celsius value plus 273.15. Same, if Kelvin is given, we have to find degree Celsius, means degree Kelvin is given, we have to find degree Celsius. So from K we are going to C. K to C means we are going backward. Backward means minus 273.15. The same degree Celsius, sorry, degree Kelvin is given, we have to find degree Celsius. So what we will do? Degree Kelvin minus 273.15. Okay. Guys, what you have to do is pause and just write on the notes what I had written here. Nothing more, nothing less. Okay, if you want to write, like as I have said you, if you want to, for your understanding, if you want to write in your own word, you can give the arrow and you can write in your own words, so you will understand the things in your own words. But for the notes and all, this much only, nothing more, nothing less. Okay. So if degree Fahrenheit is given, we have to find degree Celsius, means we'll use this formula, Fahrenheit minus 32. First what we will do, whatever the degree Fahrenheit is given, from that we'll do minus 32, and then whatever the value will get into 5 by 9. Guys, calculator is not allowed, so be careful. Now degree Celsius to Fahrenheit. Degree Celsius to Fahrenheit means if suppose degree Celsius is given, we have to find Fahrenheit. So what we will do? The value of degree Celsius into 9 by 5 into 9 by 5. Whatever you will get plus 32. Okay. And guys, see, clearing CET is very easy. Stick to the basic notes what I am giving and the PYQs plus hot questions what we will do. Very good marks you will score in CET chemistry. Okay. Understand? If degree Celsius is given, degree Kelvin means from C to K, means from lower to higher. You are moving in forward. Correct. The forward is plus 273.15. If degree Celsius is given, so degree Kelvin is given, we have to find degree Celsius means from K to C. We are going in a backward alphabetical order. So backward alphabetical order means minus 273.15. Done. So how we will get to know? We have to see that two things: which term degree is given and which degree we have to find. So which degree we have to find? Just we will check it out. If they will say find the degree Celsius, so we'll see we have a two formula for finding the degree Celsius. This formula and this formula. We have a two formula to finding the degree Celsius. Okay. So first of all, we'll get to know degree Celsius. We have to find degree Celsius. To finding degree Celsius, we have a two formula. So which formula we will use? Just we have to check. If suppose Fahrenheit is given, means you have to find degree Celsius. We have a two formula, this or this. Now next we have to see whether Kelvin is given or whether Fahrenheit is given. If Fahrenheit is given means we are going to use this formula. If Kelvin is given means we are going to use this formula. That's it. Okay, so you'll get to know which formula you have to use when. Okay, so this is the interconversion of temperature. So guys, remember one thing, sometime in the examination they will ask which of the following is a correct relationship for degree Fahrenheit and degree Celsius. So just check it out, which this or this, what is given. You have to tick any one. Okay. Now next important is significant figure. So guys, this is the important point. Significant figure are meaningful digits. So see, significant figure, how you will get the significant figure? For getting the significant figure, we have a two values in that. Okay, significant figure, first of all understand the thing, significant figure are meaningful digits because it gives the values. And which type of values it will give? It will not give the exact values. Suppose if I will tell you purchase 20 apples or purchase 5 pens. So what I am giving you exact values. So bhaiya, exact value means it will not come under the significant figure. It have infinite significant figure. Okay, so that's why exact value will not come under the significant figure. It will have infinite significant figure. So which type of value we will take in a significant figure? Which we have a approx value like 20.666789 like that. Pi value. Okay, 3.14 like that. So that type of values we will take in the significant figure. Okay, so significant figure are what? Are meaningful digit. And in significant figure we will get two type of values like this, 3.46, 51.651, anything, 1.24, anything like this type of value we will get. So significant figure means these are meaningful digit which have certain value and as well as uncertain value. So significant figure will have two values. In one value only it have two values, certain values and uncertain values. To understand the thing, so whenever you will write in decimal form, so left hand side means before the decimal, left hand side, before the decimal left hand side, this is called certain value. Certain value means fixed value. Suppose if I will tell you purchase 5 kgs of apples, so sometime you will get 5 kg 0.02. So 5 kg is what? 5 kg means it is a value before the decimal left side. So this is what? This is a certain value, means we have exact values, certain values. And then after the point right side, this is uncertain values. Okay, because see, whenever you will go for purchasing, suppose 5 kg, so sometime you will get 5 kg 100 gram, right? Suppose you went for purchasing, I said apples, not apple, not that apple. Okay, suppose you will went for purchasing apple. or any vegetables. So what will happen, guys? If you want to purchase 5 kg and you are getting 5.100, okay, so what is this? We want 5 kg. Okay, so left side of the decimal, this is a certain value what we require, and right side of the decimal, this is uncertain value, uncertainty. Okay, understand? Yes, sir. The first thing is a significant figure is a meaningful digit which has certain value and as well as uncertain value. So whenever you will write a decimal value, so left hand side or before the decimal value, this is a certain. Right hand side or after the decimal, the value is that is uncertain. Okay, fine. So significant figure is a meaningful digits. Okay, now we will see the rules of the significant figure. The first is, guys, we know all non-zero digits are significant. All non-zero digits are significant means whatever the digit you will take. Like see, 283. All non-zero. Non-zero means which does not consist of 0. So 283 is a non-zero. So 283 means 1, 2, 3. 3 significant figure. Now see 12.58. 12.58 means these all are non-zero. The non-zero digit means significant. So 1, 2, 3, 4. 4 significant figure. Here 3 significant figure. Understand? So all non-zero digits are significant. Next, 0 preceding. See, preceding means suppose this is a value, some value. Preceding means before. Okay. Zeros preceding to first non-zero digit are not significant. Means see, these are the zeros which is preceding means what? Before or left side of any non-zero digit. So that's what they all are not significant. Like here 0.0052. So you can see these zeros are the preceding value to this non-zero digit, or these values are before the values of non-zero digit. So these zeros which is present before the, yes, the zero which is present before the non-zero digit is not significant. So here you can see these zeros will consider not significant, only 5 and 2. So 2 significant figure. Here like 0.03. So what will happen? These are the zeros which is preceding to the non-zero digit. Preceding means before the non-zero digit. So this is not significant. Only we have one significant, like this 0, 0, 0, 4, 6, 7. Okay, so what we will see, these zeros are the preceding values to this non-zero digit, or these zeros are before the non-zero digit. So before the non-zero digit, the zero digits are not significant. Only 1, 2, 3 significant figure are 3. SF means, guys, significant figure. Okay, now zeros between two non-zero digit are significant. Zeros between two non-zero digit are significant. So guys, see, 0 between two non-zero digit, apply whatever you want. So what is, these are the zeros between two non-zero digits. So these all are significant because it have some values. If I will write to this 208, if suppose this is like 678, if I will put the 0 here, 67008, now value is 67,008. So what is happening? The value is changing. Okay, so that's why 0 between the two non-zero, two, see, this is a two non-zero, 7 and 8 is a two non-zero. The 0 between two non-zero digits are significant. So here significant figure is 1, 2, 3, 4, 5, 6, 7, 8. 8 significant figure. Here 1, 2, 3 significant figure. This we know all non-zero digits are significant. So 3 significant. This is the 0 between the two non-zero digits. These are significant. So 1, 2, 3, 4, 5 significant figures. Correct? Yes, sir. Okay, as I'm saying you, whatever the things I had written here, you should have to write. This is the main notes. Other than that, you are listening this video and you are understanding the things properly. So for your understanding, if you want to make a notes of 1 line, 2 lines, so that's what this point means related to this. So it will be useful for you to remember in the future. So you can write that. Okay, but these are the sufficient notes. Okay, see guys, if you are in 11th moving to 12th, please watch all the videos of class 11th. Don't see for 12th. Okay, please watch all the videos for class 11th. Your class 11 CET concept will get clear 100%. Okay, then when you will finish the class 12th, then you can watch for class 12th. Okay, and the student who's completed the class 12th, you can watch. This is a crash course for you, but in the crash course I'm explaining in a detail, so that's why I'm making for every chapter two part. First video of a concept, second video is of PYQ and hot questions. Okay, next, zero at the end or right of a number are significant. Okay, understand, if you are writing, see, if you are writing 0 before the significant figure, correct, just before law, see, before rule, this rule I'm talking about, this rule, this rule are very much confused part and very much linked with each other. So guys, in this what we studied in this, sorry, not this one, not this one guys, this one, yeah. In this what we studied guys, in this we studied that any zero you will take preceding of the non-zero digit, means any zero you will take before the non-zero digit, before the non-zero digit, it is not significant. Okay, now these two what they are saying, they are talking about zero which is after the non-zero digit, or you can say zero which is present at the end of non-zero digit. Okay, or zero which is present on right side. So all the three which means same, zero which is present at the right side of non-zero digit, or zero which is present at the end of non-zero digits, or zero which is present on like after the non-zero digit. Okay, zero which is present at the end of non-zero digit, zero which is present after the non-zero digit, or zero which is present on right side of the non-zero digit, all means same only. Okay, so that is guys very important thing. See here, these two, well, this two law I will write it here, then I will explain it, very important. See that this law what it says, this law says that whatever you apply the zero before the non-zero digit, whatever the zero you apply before the non-zero digit, the zero you will apply before the non-zero digit, the zero you will apply before the non-zero digit, and zero you will apply before the non-zero digit, whether it is in the form of decimal or whether it is not form in a decimal, zeros are not significant. So here just we have two significant figure, here we have three significant figure. Okay, so zero before the significant figure, or zero preceding the significant figure, or zero on the left side of the significant figure, whether it is decimal or whether it is not a decimal, so all these zeros are not significant. Okay, but what this part is saying, this part is saying if we'll apply the zero at the right side of the non-zero digit, zero at the right side of the non-zero digit, or zero which is present at the end of non-zero digit, is all significant when provided they are on right side of decimal, right side of decimal. So 1 2 3 4 5. But suppose if I am writing a zero, if I am writing a zero after the non-zero digit, see here guys, here I have written the zero before the non-zero digit, here also I am written the zero before the non-zero digit, here I am writing the zero after the non-zero digit, here also I am writing the zero after the non-zero digit, but concept are different. Understand, if you are writing zero before the non-zero digit, and whether the number is in the decimal form or the number is not in the decimal form, all the zeros which are before the non-zero digits are not significant. The only 2 3, that is a significant figure. Okay, once again, zero which is present on the left side of a non-zero digit, so these, okay, zero which is present on the left side of a non-zero digit, So whether that number is in the form of decimal or whether that number is not in a form of decimal, so all the zeros which are present on the left side of a non-zero digit are not significant. Okay, but coming to this two part, 0 present to the right of a non-zero digit. Okay, 0 which is present to the right of non-zero digit, and we are writing in a decimal form. If it is in a decimal form, then this 0 is significant. We will count that 0. So 1, 2, 3, you can see 0 which is present on the right side of a non-zero digit, but this number is in the form of decimal. So we will count this 0. So it will become 1, 2, 3, 4, 5 significant figure. But same thing, if you will see this, these are the zeros which is right side of a non-zero digit. But we will see here we don't have decimal. So what will happen? These zeros are not significant. Only 2 significant figure. Okay, crystal clear? Yes. That's what it says. 0 at the end or right of a number are significant when provided they are on right side of decimal. Decimal should be there. You can see here. This is a 0 on right side of a number. But what, this number is in a decimal form. So this 0 is significant. 1, 2, 3, 4, 5 significant. But see, same here, this is also a 0 which is present on right side of a number, right side of a non-zero digit, but this whole number is not in a form of decimal. If that is not in a form of decimal, then this 20 is not significant. Only significant figure is just 1. Okay, see here, 100.0. So this all 0 is present on right side of a non-zero digit, but we will see this whole number is a form of decimal. It is in a form of decimal means we will count this 0. So 1, 2, 3, 4 significant figure. Same, see here, 4, 6, 3, 0, 0, 0. You can see here these zeros are present on right side of a non-zero digit, but we will see this whole number is not in a form of decimal. So if this whole number is not in a form of decimal, then what we will do? Then the 0 which is on right side of the number is not significant. Only 1, 2, 3 significant figure. Understand? Once again I will tell you, if the number is decimal or if the number is not decimal, number is written in decimal form or the number is not written in decimal form, in both the condition, if zeros are present on left side of non-zero digit, that all zeros are not significant, whether we are writing in a decimal form or whether we will not write in a decimal form. Okay, now next is, if we are writing in decimal form and 0 is present on right side of a non-zero digit, so that zeros are significant, means that 0 we will count. Okay, this too is the example. Okay, this too is what, the number is in the form of decimal. If the number is in the form of decimal and zeros are present on right side of a non-zero digit, then these zeros are significant, we will count it. Okay, next, if number is not present in decimal, if number is not present in decimal, so any 0 on the right side of a non-zero digit are all not significant, we will not count it. Done? Yes. See, counting the exact number of object have infinite significant figure. Starting only I told, if you have an exact number, then it is an infinite significant figure. In the examination, if they will ask, don't take that they have no significant figure or they have 0 significant figure. No, if you are taking that option, it is wrong. You have to take they have infinite significant figure. They have infinite significant figure. Okay, yes, because see, 20 bats means what? Suppose if I will tell you 5 kg means what? 5.00000. Where the 0 will end, we don't know. So that's why you can see this is a form of decimal. This is number in the form of decimal, and the zeros which is present on right side. Okay, if number is in the form of decimal and the zeros are present on right side of non-zero digit, all are significant. So 5 kg means what you will write? 5.00000, right? So 00000, when it is ending, we don't know. So that's why infinite significant figure. Okay, now next, See, this is very important. This two note is very important. This two note is very important. See, when adding or subtracting numbers, you will get the two numbers. You have to add or subtract. So what will happen? The rule of significant figure is to round the final result to the number with fewest decimal place. Means, see here, I will show you. Suppose if you will get addition or you have to subtract. Okay, what we have to do? We have to do addition or we have to subtract. So whatever the final result you are going to get, you have to write in the form of fewest decimal places. Okay, fewest decimal places means like this. Yeah. Where it will come. See here. If you have to add the number, wait. So here. See, if you have to add or subtract a number, suppose like this: 12.11, 18.8, 1.012. What we did? We added it. Okay. So if we have to add the number or if we have to subtract the number, whatever we will do, if we have to add the number or if we have to subtract the number, whatever the final number you are getting, whatever the final result you are getting, you will round off to fewest decimal places. Fewest decimal places means, see here, this is the 1 value, 2 value, 3 value. So in this 3 value, which is the fewest decimal places, means, see, fewest decimal places means after the decimal. Don't see before the decimal. After the decimal, which is fewest number. Means after the decimal we have 2. After the decimal we have 1. After the decimal we have 3. So which is the fewest? 1 is the fewest. So you have to write in the form of fewest decimal number. So just understand the concept. When we will do the sum, that time you will understand. When you will do the PYQs and HOTS question, that time you will understand. Just understand this much. If you are adding or subtracting a significant figure, so whatever the final answer you are getting, what we have to do? Round the final result to number with fewest decimal places. Fewest decimal places means we will see after the decimal. After the decimal, what is the least decimal value? So after the decimal we have a 2 digit. After the decimal we have 1 digit. After the decimal we have 3 digits. So what is the fewest, guys? 1. So we have to round off to 1. Okay, 1 digit. So how it will become? See, 31.122. So 31 will remain as it is, and decimal I will keep as it is. Now I have to round off to fewest decimal. The fewest decimal is what? 1. 1 is the fewest decimal. The fewest decimal places means 1. So we have to round after the decimal. We have to round till just 1 digit. The 1 digit means what? 1. 31.1 is the answer. If suppose here 18.00 is there. So what is the fewest? Fewest decimal places, this is also 2, this is also 2, this is 3. So fewest decimal places is 2. Fewest decimal places means after the decimal, 2 digit. So this we are going to round off to 2. 2 means 31 we will write as it is, 31 we will write as it is. Then after decimal we have to write 2 digit. Fewest decimal places means, what is the fewest? Fewest is 2. So means after that we have to write just 2 digit. So 1 2 means 1 will be as it is. Then remaining is what? 2 2. 2 2 means 22. 22 will round off to 20. So 31.12. Okay, round off, you know, everyone knows round off. So like this for addition and subtraction. Next, when multiplying or division numbers, the rule of significant figure is to round the final result to lowest significant number. So I see, whenever you will multiply or divide, what you will do? See, this you multiplied, this is a 2 significant figure, this you multiplied, this is 3 significant figure. The final result is getting in 4 significant figure. But what we have to do in multiplication or division, we have to see which is having lowest significant figure. Guys, understand, in addition and subtraction we will do normal addition, we will do normal subtraction. In that, whatever the final result we will get, we will round off to fewest decimal places, means least decimal places. In all the addition values or in all the subtraction values, we have to see which is the less decimal value. Less decimal value means after decimal which is having less number of digits. So whatever the less number of digits, we have to round off till that fewest decimal digits. But in multiplication and addition, we will do the normal multiplication method or we will do the normal division method. But whatever the final answer you will get, you have to round off to lowest significant figure. As in addition and subtraction, lowest decimal place. In multiplication and division, lowest significant figure. Just understand the concept. And like this example, when we'll do the PYQs and HOTS questions, then you will understand it crystal clear. Okay, addition and subtraction, you will do the normal addition, normal subtraction. After that, whatever the final value you will get, so we will see that which is having least decimal value, we will round off to that decimal value. Okay, least decimal value. But in multiplication and division, we'll do normal multiplication, we'll do normal division. Whatever the final answer you are getting, that final answer will round off to lowest significant value. So lowest significant value is, this is 2 lowest significant value. So this will be round off to 2 significant value, means 3.1. 3.1, 2 significant. Understand? Yes. So when we'll do adding or subtraction, what will happen? Round the final result to fewest decimal places. Just understand the concept, guys. Now when in the next video when we will solve the PYQs and hot question, you will understand. Okay, so what will happen? Adding or subtracting, we will round the final result to number with fewest decimal places. But when multiplying or division, we'll round the final result to lowest significant number. So addition and subtraction, we will see the lowest decimal value, but in multiplication and division, yes, we will see the lowest significant value. Okay, done. Next is law of chemical combination. Law of chemical combination, first is law of conservation of mass. Very simple, guys. Who has given this law? Anthony Lavoisier has given this law in 1789. What does this law says? Because we know law of conservation of mass. Very, guys, from childhood we are studying this law of conservation of mass, law of conservation of energy. So what will happen? In all physical and chemical change, there is no net change in mass during the process. Guys, there is a no net change. Understand this word, no net change. Guys, normal changing will be happening, but when you will count the overall change, so no, zero. Net change is zero. That is important. In all physical and chemical changes, there is no net change. Normal process change is happening, but when you will count the net change or overall change, there is no, means zero net change or zero overall change in mass during the process. Okay, the reason behind is mass can neither be created nor be destroyed. So we can't create, we can't destroy. So overall net change is zero. So total mass or total atom remains conserved, because this is a conservation, so it will remain conserved. So law of conservation of mass is applicable if there is a balancing of chemical reaction, means chemical reaction is balanced, then only the law of conservation of mass is applicable, otherwise it is not applicable. Then what we will see in the law of conservation of mass? Total mass of reactant equals to total mass of product. So whatever the total mass is present on reactant side, the same total mass should have to be present on product side. How it will be possible? It will be possible only if the chemical reaction is balanced. If the chemical reaction is balanced, we know in balancing what will happen? Total number of atoms which is present on left hand side and the total number of atoms which is present on right hand side, both are same. So that's why total mass of reactant will be equals to total mass of product. Okay, means like this. N2 plus 3H2 gives 2NH3. First of all, we have to see this chemical reaction is balanced or not. If it is not balanced, then it will not follow the law of conservation of mass. It is balanced, then only it will follow the law of conservation of mass. So N2, we have 2N. So yes, guys, 2N. Then 3 to the 6 hydrogen. So 2, 3 the 6 hydrogen. So yes, this is balance. So see, mass of reactant. Mass of reactant means N2. What is the atomic mass of nitrogen? 14. N2 means 14 to the 28 gram. And this is what is the atomic mass of hydrogen? 1. Here how many hydrogen are there? 6. So 6. So 28 plus 6, mass of reactant is 34 gram. Now we'll see the mass of product. Mass of product is nitrogen. How many nitrogen are there? 2 nitrogen. The 14 to the 28. Plus how many hydrogen are there? 6 hydrogen. So 1 into 6, 6. 28 plus 6, 34 gram. Yes. The mass of reactant equals to mass of product. Law of conservation of mass, and this is only applicable when, yes, chemical reaction is balanced. The balancing of chemical reaction is very important. This is important, guys. This law is not valid for nuclear reaction. Law of conservation of mass is not valid for nuclear reaction. The reason behind is in nuclear reaction mass is not conserved. Right, nuclear reaction, it is reacting, the mass is not conserved there. Next is law of constant or law of definite proportion. So this is given by Joseph Prost in 1799. What it says? The simple thing is that a given compound means whatever we will take a compound. Suppose we have to prepare CO2, or if we have to produce water. So a given compound always contain exactly the same proportion of element by weight. So a given compound, whatever the compound you want to produce, suppose we want to produce H2O water. So in H2O water, guys, every time, see, if we a given compound means, suppose I will tell you that given compound is water. I have to produce water. So guys, see what they said, a given compound water always contain exactly the same proportion of element. Same proportion of element means water means what? In water we have a 2 gram of hydrogen and 16 gram of oxygen. So 2 is to 16, the 1 is to 8. So same proportion of element by weight irrespective of source or method of preparation. Means if we have a given compound as H2O water, so we will see that its elements are present in same proportion. We will not care about its what are the source, which source we are getting this water, or what is the method of preparation of this water. We will not see. Just we will see that final product is water. We have to get water. That's it. Final compound is CO2. We have to get CO2. And the CO2, what you will see, the element every time, guys. If I will tell you carbon dioxide. So what is the carbon dioxide? CO2. Carbon dioxide is what? CO2. So given compound means we will not see carbon dioxide, means CO2. We will not see which source we are getting CO2, either by combustion or either by when plant will release by photosynthesis and all. So we will not see that method of preparation, or will not see by which source we are getting carbon dioxide. Our main aim is to get a final compound which is carbon dioxide. And after getting carbon dioxide, what is the formula? Carbon dioxide formula is CO2. The CO2 means 12 gram of carbon and 16 to the 32 gram of oxygen. So 12 is to 32. When you will cancel this, you will get 3 is to 8. Means that is the thing. Law of constant or law of definite proportion says that a given compound, fix a given compound, water, ammonia, carbon dioxide, fix a compound. And fix a compound means once you fix the ammonia, NH3. So we will not see its method of preparation, we will not see its source of getting. Just we will see that ammonia means NH3. So in NH3 means what will happen? Its element should be present in same proportion. Element should be present in same proportion. That's it. Law of conservation of law of definite proportion says that whatever the compound you will take, its element should be present in same proportion. So H2O, we will not see from which source we are getting. We are not see which method of preparation we are using. H2O, either I will bring that H2O, salt water, sorry, from sea I will be bringing H2O, or I will bringing H2O from Australia, or I am bringing H2O from my house, or I am bringing H2O from your house. I will not see source or how I am preparing H2O. I will not see the method of preparation. Final result is H2O. So whenever we have a final compound H2O, so every time H2O means its elements are in same proportion, that is 1:8. Okay, that's what law of constant proportion says. It is not valid in case of isotope. It's not valid in case of isotopes. The reason behind is, we know isotopes, right? Isotopes is what? Yes, isotopes क्या है देखो, Okay. Isotopes means, guys, see, isotopes have same atomic number but different mass number. So what will happen? Mass number will differ. If mass number will differ, we cannot able to do this. We cannot able to fix in a same proportion. The reason behind it, a given compound always contain exactly the same proportion of element by weight. It's not seen by atomic number, by weight. Weight means what? By atomic mass. Okay, so isotopes, it's not valid in case of isotope. The reason behind in isotope, we have a different atomic mass. The different atomic mass means weight will keep on changing. Weight will keep on changing means will not have a same proportion. Okay. Now next is law of multiple proportion. See, law of multiple proportion is very simple, guys. We have to take two elements are reacting with each other to give two or more than two compound. Here we will get the two compound. See, two elements react where we will get a more than two compounds, two or more elements. So see, whenever you will see that two elements are reacting and it is giving more than two compounds, two or more than two compounds, it is a law of multiple proportion. See, multiple. Okay, so law of multiple proportion is given by Dalton in 1803. So what is this? When one element combined with other element, when one element combined with other element, one element combined with other element to form two or more different compound, what will happen? The mass of one element which combined with the constant mass of other element give the simple whole number ratio. Means one element combined with other element, so we will get two or more than two compounds. So two or more than two compounds. So whatever you will get in that, what will happen? We will fix the mass of one element and other element mass will keep on changing, like plus H plus O2, we will get H2O water or we'll get H2O2. Okay, hydrogen peroxide. So what will happen, guys? See, we have a two elements react with each other to give two or more than two compounds. So here we are getting two compounds. The mass of one element which combined with a constant mass of other element. So this mass of one element means this oxygen mass, which is what? Combining with a constant mass of hydrogen. You can see we have a 2 gram of hydrogen reacting with 16 gram of oxygen. So again here this also 2 gram of hydrogen reacting with means is to 32 gram of oxygen. So I see we have a fixed constant mass of other element and this oxygen mass is changing. So what will happen? It will give a simple whole number ratio. Simple whole number ratio means 16 is to 32. 16 is to 32 means 1 is to 2. That's it. Okay. So this is the thing. Law of multiple proportion means what it says. It says that if we will take two elements reacting with each other and we will get more than two or more compounds, and what we will see in two or more compounds, one element value is constant, they have constant mass, and other element will change the values. We have the two elements. First means one element will have a constant mass, other element mass will keep on changing. Like see, carbon reacts with oxygen, we have a two elements getting two compounds. Okay, so what is happening here? Here carbon and carbon remain same constant mass, but oxygen masses keeps on changing. So if keep on changing also, they are in whole number ratio. See, whole number ratio. So when it is not valid, it is not valid for non-stoichiometric compound. Non-stoichiometric compound means you will get like this: N is 1.7, O is 3.1. So this is not a whole number ratio. So for that it is not valid. Like see, X is 1.7, Y is 3.9. So this is not a whole number ratio. So for this it is not valid. Okay. Now see, law of conservation of mass means we know. First of all, we want it in a balanced chemical reaction. Then we will find the mass of reactant should be equals to mass of product. Done. Now when we will come for the law of constant or law of definite proportion, it says that simple thing. We have a one final compound. We have a one final compound. So we have to form a one final compound. We will not see which source I am getting, or will not see which method of preparation I am getting. We will not see that irrespective. Just we have to form that compound. Whenever we will form that compound, their elements will be in same proportion. That's it. H2O. Every time we'll form H2O, 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 H2O. We'll not see which source I am getting H2O, and will not see which method of preparation I am getting H2O. Irrespective of this, final compound should be H2O. So what happened? Its element are in same proportion, that is 1:8. That's it. Want to say law of constant or law of definite proportion. Now law of multiple proportion. Law of multiple proportion, it wants to say that every time we will take just two elements. We will not take three elements, we will not take one element. We will take two elements. With two elements we will get two or more than two compound. That is the first condition for law of multiple proportion. First condition is what? We will take only two elements. With two elements we will get two or more than two compounds. Okay. In that the value of one element should be have a constant mass, and the value of other elements keeps on changing. Value of one elements have a constant mass, value of other element keep on changing, and it is not valued for this type of non-stoichiometric compound. Means this, the ratio should be in whole number ratio. If it is in a fraction or if it is in a decimal form, it is not a law of multiple proportion. We want a whole number ratio. Okay, fine. Now see N plus O2. You can see, sir, NO2, N2, NO, NO2, N2O, N2O3, N2O4. Here we don't have a same. See, O is also changing, N is also changing. But what we have to do? Constant mass means we have to keep one element mass as fixed. If we will keep the nitrogen N2 mass as fixed, N2 means what we will get here? This is N. We have to convert into N2. Means we have to do this 2. So to N2. Here also nitrogen is 1. We will do 2 N2. So now see here. Here we have fixed mass of N2 means this is N2. This is N2. N2, N2, N2. Masses of N2 are fixed. Now masses of oxygen are changing. It is what? 2 oxygen. This is 2 to the 4 oxygen. This is 1 oxygen, 3 oxygen, 4 oxygen. Masses of oxygen is changing. Means masses of other elements are changing. But the mass of one elements are fixed. So if it is given, guys, H2, H2, C, C, we can know we have to fix this. If it is given like this, so you have to fix the mass. After fixing the mass, write in a balanced form. So that's why you will get the mass is fixed. After fixing the mass, write in a balanced form. So that's why you will see the masses are fixed. And other masses keeps on changing. And then what we will see? They are in the whole number ratio. They are in the whole number ratio. This is not a whole number ratio. This is a decimal ratio. The decimal ratio is not valid. Decimal ratio is, or fraction ratio is not valid. The ratio should be whole number. Understand? Law of multiple proportion is what? Only the two conditions. First condition is we have to take only two elements. With two elements we'll get two or more compound. Okay, in that what we have to do? In that we have to fix the mass of one element. The one element mass will remain fixed. Other element mass keeps on changing, and they are in whole number ratio. This type of things is not valid. Okay. Now Gay-Lussac's law. Gay-Lussac's law of gaseous volume. भैया देखो Gay, I don't know why their parents keep the name like that. Okay, Gay-Lussac's law of gaseous volume is given by Gay-Lussac in 1808. Simple thing, guys. Gay-Lussac's law of gaseous volume. First of all, its condition is it should be gaseous. We'll take the volume of gaseous. If suppose like this, if you are writing any reaction in that gas, suppose solid, gas, liquid is present, we will, that whole reaction part is we will not take. We will take only for the gaseous volume. Okay, so what it says, very simple thing, guys. When gases combine or are produced in a chemical reaction, they do in a simple whole number ratio by volume, provided all gases are at same temperature and pressure. So what we have to do, Gay-Lussac's law is, first of all, is it will be applicable for gaseous. Okay, second thing, it says that when the gas is combining or when the gas is producing, okay, what will happen? They should be in a simple whole number ratio. They should be in simple whole number ratio by volume, because gas will take in volume. Provided, what is the condition? All gases are at same temperature and pressure. Let's see, N2 is a gas plus 3H2 is a gas, we'll get 2NH3 is a gas. So suppose we have a 1 liter volume of 1 liter of N2, volume of 3 liter of H2O, and we are getting a volume of 2 liter of 2NH3. So what guys? They are in a simple whole number ratio by volume. To see, simple whole number ratio of volume is 1 is to 3 is to 2. So they are in a simple whole number ratio. If it is present in fraction form, or like what you can say, decimal form, it won't like satisfy this. Okay, so Kcet's law is what? First of all, we have to see the volume of gases. Okay, volume of gas, and that volume of gas should be present in simple whole number ratio. Okay, it should not present in fraction, it should not present in decimal. First of all, what we will take? We'll take the volume of only gases, and that volume of gases should be present in simple whole number ratio. It should not be in decimal, or it should not be in fraction. Now Avogadro's law. Avogadro's law is given by Avogadro in 1811. Very simple guys. Avogadro's law, what it says, that equal volume of all gases, So whatever the gases we are taking, we have to take the equal volume of all gases. Suppose I am taking CH4 gas, O2 gas, SO3 gas. So what is the condition? First condition is equal volume of all gas. To see, equal volume, 5 liter of this gas, 5 liter of this gas, 5 liter of this gas. So equal volume of all gases at same temperature and pressure, means at STP. Temperature and pressure we are not going to change, we will keep same. So equal volume of all gases. To see, equal volume of all gases at same temperature and pressure should contain equal number of molecules. So guys, equal number of molecules. So for finding the formula for finding the number of molecule is what? This will find the number of moles into Avogadro number. So guys, whatever we will take the gases, if we'll take the equal volume, see here, we are taking the equal volume, of all the gases. So it should contain equal number of molecules. So for finding the number of molecules, we have a formula of number of moles into Avogadro number. So guys, see, number of moles we will find for CH3. Number of moles is what? Given volume by STP means 22.4. STP means what? Volume will remain fixed, 22.4. Same number of moles of O2 is also given volume 5 by STP means 22.4. The number of moles of SO3 is also same, 5 by STP is 22.4. So number of moles we will get to know into Avogadro number. Avogadro number will remain same. So you can see number of molecules for CH4, 5 by 22.4 into Na. Number of molecules of O2, 5 by 22.4 into Na. The number of molecules of SO3, 5 by 22.4 into Na. So what we are seeing? Equal volume, we are taking equal volume of all gases, that is 5 liter, 5 liter, 5 liter. So equal volume of all gases are giving, what they are giving should contain equal number of molecules. See the molecules, the equal molecules, all is having equal molecules. So how we will find the number of molecules? We will take the number of moles into Avogadro number. The number of moles means given volume divided by STP. So that's why we want at same temperature and pressure. So STP will remain same, 22.4, 22.4, 22.4 into Avogadro number. Avogadro number will remain same for all. So what we understand, if you will take the equal volume of gases, see, if we will take equal volume of gases, so what we will get? We will get equal number of moles. See, the moles are same. The reason behind is volume, given volume will remain same. So we are taking at standard temperature and pressure. So this 22.4 will also remain same. So if you are taking equal volume of gases, we are getting equal number of moles and we are getting equal number of molecules. This is what Avogadro law says. I see, we have seen for finding the number of molecule formula is number of moles we will find into Avogadro number. Same if you have to find the number of atoms, very important in the examination they asked. For finding the number of atoms, what we will do? First we will find the number of moles into Avogadro number into atomicity. We will get the number of atoms. Now Dalton's atomic theory. Dalton's atomic theory means what? Matter is made up of small indivisible particles called atoms. Atoms of same element have identical properties while atoms of different elements different in properties. Okay. So these are the law they can ask in the examination. Atoms of means these are theory they can ask. Guys, see these law na, this is important because sometime in the examination they will write the statement and they will ask which law, or sometime in the examination they will write the law name, you have to take the which statement is suitable for this. Okay, sometimes they will give the example in the written form and they will ask you, tell me this example belongs to which law. Okay, I hope every law is crystal clear to you. Now atoms of different elements combine in fixed ratio to form compound. As we know, in compound and mixture, what is happening? Atoms of different elements are combining. In compound, atoms of different elements are combining, we are getting compound. Mixture is also same, atoms of different elements are combining and we are getting mixture. But the thing is, in compound we have a fixed ratio. In mixture we don't have a fixed ratio. Understand one thing? Compound also atoms of different elements are combining to form compound. Here also atoms of different elements are combining to form mixture. Okay, both we are for forming the compound, for forming the mixture we are taking atoms of different element, but for compound we will take a fixed ratio. They will combine in fixed ratio, but in mixture there is no fixed ratio. Okay, so atoms can neither be created nor be destroyed in a chemical reaction. Chemical reaction involve reorganization of atoms. Reorganization of atoms means what? Reactant will react with each other and we will get a product in a balanced form, so reorganized form. Okay, this is important point. Reorganization of atom will only happen in Dalton's atomic theory where we have a balanced. So this theory could not explain the law of gaseous volume. Okay, atomic mass and molecular mass. Guys, atomic number we know and atomic mass we know. So atomic mass means mass of an atom, which was represented in AMU but now it is represented in U. U means unified mass. Okay, so what is AMU? In the examination they can ask. One AMU is defined as mass unit which is equal to exactly 1/12th mass of one atom of 12 carbon isotope. This is your definition. So one AMU value is 1.66 into 10 to the power of minus 24 gram. Now average atomic mass. See, average atomic mass we know elements in the periodic table have isotopes. So elements like hydrogen. A hydrogen is what? Hydrogen we have isotope 11, 21, 31. So atomic masses are changing. So elements in the periodic table have isotopes. So what will happen if you take the elements which is present in the periodic table, that element is having isotopes. Isotopes means they have a same atomic number but different mass number. So if any element like hydrogen is having different mass number, so how we will find its atomic mass? So we will add all the atomic mass divided by how many isotopes it have. We will get the average atomic mass. So that's the element in periodic table have isotopes. One element is formed in a different isotopes. The isotopes mean they have a different mass number. So what we will do? We will take the atomic mass of such element. We will do the average of atomic mass of its isotope. We will get the average atomic mass. So average atomic mass means we will add this all the atomic masses divided by total number of isotopes what is present. I see molecular formula or formula mass. We know how to find the molecular formula. It is nothing but we have to do the sum of atomic mass of element present in a molecule. Correct? Everyone knows how to find the molecular formula or formula mass. Now mole concept. Mole concept is what? Mole is the unit of measurement. Mole, obviously guys, we know mole is a unit of measurement used to express amount of substance that contains elementary particles. Okay. Avogadro number. It is what? Avogadro number. 6.022 into 10 to the power of 23. If you will see Avogadro number, so amount of substance that contains the elementary particle is 6.022 into 10 to the power of 23. That's what the molar concept used to say, that it is unit of measurement. What unit of measurement? It will express that the amount of substance, this is the amount of substance that contains the elementary particle, this. Okay. So guys, see, N indicates the number of moles. We have a three formula for finding the number of moles. So number of moles formula changed based upon what is given. Number of moles formula changed based upon what is given. If suppose weight is given and we have to find number of moles, means yes, the formula is given weight by molar mass. If number of particles is given and we have to find the number of moles, means number of particles divided by Avogadro number. If volume is given and we have to find the number of mole, means given volume by 22.4 STP. This is a formula, three formula for finding the number of moles based upon what is given. Now percentage composition, we know percentage composition is nothing but we have to find the percentage of an element. Like suppose in CO2 we have to find the percentage of oxygen. So what is this? This is a percentage composition, right? Percentage of an element. So in CO2 we have to find the percentage of oxygen. So oxygen is an element. So what is the formula for percentage of an element? Mass of an element in the compound. Guys, very important. See what in the examination the student will do now. In CO2, if they will say percentage of oxygen, means they will see that, oh, we have to take the mass of an element. Oh, what is the mass of oxygen? They will take 16. No, it's a wrong. What they said, mass of an element in the compound, means what we have to do, we have to find the percentage of an element, that is oxygen. The mass of an element is what? 16 present in the compound. So in this compound how many oxygen is present? 2 oxygen. So we will not take the mass of element is 16 only, we will take 16 into 2, because mass of element in that compound, what is the mass of oxygen? The oxygen is 2, the mass is 32. We will not write just 16. Okay, so mass of element in that compound, the mass of oxygen in this compound, the mass of oxygen in this compound is 16 into 2 divided by molar mass of the compound, molar mass of compound into 100. You will get the percentage of an element. So what is this? It is a relative measure of mass of different element present in a compound. Mass of different element present in a compound. Now empirical formula. Guys, empirical formula we know what it gives. It gives the simplest whole number ratio. So that's why we can able to make the formula now. Any formula like CH4, any formula CH4, what do we have? We have a whole number ratio. So every time whenever we will take the ratio, it should be simplest whole number ratio. We have studied previously also, right? It should be simplest whole number ratio. So it gives the simplest whole number ratio of atoms of different element present in a compound. Atoms of different element, CH, different element present in a compound. Like CH4, we have a, see this is a compound present in a compound, means this is a compound CH4 and different element is what? Carbon and hydrogen. So they are present in what? Whole number ratio of atoms. Whole number ratio means 1:4. 1:4. So that's it. It gives the simplest whole number ratio of atoms of different elements present in a compound. It should be simplest whole number ratio. So guys, how we are going to find the empirical formula? You already studied in your PUC how you find the empirical formula. First, what we will do? First, we will convert the mass percentage to gram. Whatever the mass percentage is given, we will convert into gram. Suppose they will give carbon and hydrogen, 60% of carbon, 40% of hydrogen. So what we will do, we will convert the mass percentage into gram. We will convert the 60% means into gram, means it will be 60 gram, hydrogen is 40 gram. That's it. The value will remain same, just in place of percentage we will write the gram, we know. So we will convert the mass percentage into gram. Then after it we will find the number of moles. For each we will find the number of moles. We will find the number of moles of carbon, we will find the number of moles of hydrogen. The formula for number of moles is given mass by atomic mass. Given mass by atomic mass. Then what we will do? We will get the number of moles of carbon, we will get the number of moles of hydrogen. Then divide each value of mole by smallest value. So we will see in this two value of a number of mole which is having smallest value. So in that we have to divide the both number of mole. So divide each value of mole by smallest value. And then what we have to write? We have to write down the empirical formula. This concept we know, guys, this method we know, and we know how to find the empirical formula. So here just I am explaining you in a brief way how to find the empirical formula. When we will do the PYQs and hot question, that time you will understand. Okay, yes bhaiya. अरे आओ रे भैया. Now guys, molecular formula. Molecular formula means what? It shows the exact number of. It shows, this is very important in the examination. They can ask. Empirical formula is what? It gives the simplest whole number ratio. This simplest whole number ratio of atoms of different element. Atoms of different element present in a compound. It should be the simplest whole number ratio, and we know how to find the empirical formula. You already did in your board also, they asked in the examination, and you know how to find the empirical formula. So molecular formula means it shows exact number of different types of atoms present in a molecule of a compound. Very important is it shows the exact number. Okay, for finding the molecular formula, what is the formula? We know N into empirical formula. N is what? N, how we will find? Molar mass, which is given in the question. The molar mass which they will give in the question divided by empirical formula mass. So what we have to do? First we have to find the empirical formula. After finding the empirical formula, we have to find N. For N, molar mass by empirical formula mass. So molar mass which is given in the question, they will give in the question, divided by, with empirical formula we know how to find the empirical formula mass, right? So suppose empirical formula is CH4. So we know how to find the empirical formula mass. Carbon is what? 12 plus hydrogen is 1 into 4. So 12 plus 4, 16. This is empirical formula mass, we know. So molar mass by empirical formula mass will get N. Then N into empirical formula. Okay, we will get the molecular formula. You have already studied in the board, you know how to do this. Okay, so just understand the concept here. When we will do the PYQ and hot questions, there we will understand. Now, so this is a concept, just I am learning this basic term, basic definitions and all. Already you studied. This is a crash course, means what? I am not going to teach you in a detail how it came, how and all. This already you studied in the PUC, like class 11. The examination it came, you practice for the examination, you worked for the examination, so you know this thing. Okay, chalo yeah. Concentration term. So for finding concentration term, you have to concentrate. Concentration term first is what? Mass percentage. Mass percentage is nothing by are oh pyare. This is similar to the percentage composition. What we have to do? We have to take the mass of an element in the compound divided by molar mass into 100. The same here. See, concentration terms means first is mass percentage. Mass percentage, guys, see, solute plus solvent will get solution. All we know. See, what we will say in life, if you have a stress, depressed and all, you will say suicide is the solution. Suicide is the solution. I cannot able to do in my life. I got failure in my life. I am failure in my life. My girlfriend left. My boyfriend left. Blah 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 blah. You will say nothing. Suicide. Suicide is the solution. No, bhaiya, suicide is not the solution. Solute plus solvent is the solution. Understand? Be a chemistry student, don't be a biology student. So suicide is a solution. Solute plus solvent is a solution. If anyone say, what is the solution? What can I do for this? What is the solution? You don't say suicide is a solution or give up is a solution. Never give up. For the examination, don't say give up is a solution. Say solute plus solvent is a solution. Means you have to mix your hard work, discipline, dedication, everything you will mix, and then you will get a solution. Okay, suppose solute I will take A and solvent I will take B, and we have to find the mass percentage of solute. The mass percentage of solute in a solution. So what we will do? We will take the mass of solute divided by total mass of solution into 100. Now mole fraction. Mole fraction is denoted by you will say X. Yeah, by X. Come out from your X. Move on guys from your X. This is not X. This is a chi. Okay, not kite. Chi. Mole fraction. So guys, suppose if you have to find the mole fraction of A, means mole fraction of solute. See, as I just for I have take as a reference solute is A, solvent is B. So if you have to find the mole fraction of A, means mole fraction of solute is not X. Move on. Yeah, move on. This is a chi. So mole fraction of A means we know the formula. Number of moles of A divided by number of moles of A plus number of moles of B. So this is the representation, number of moles of A divided by number of moles of A plus number of moles of B. The formula is what? Number of moles of A means given mass by molar mass of A divided by number of moles of A means given mass by molar mass of A plus number of moles of B means given mass by molar mass of B. That's it. Suppose if you have to find the number of mole fraction of B. The mole fraction of B means number of moles of B, yes, divided by number of moles of A plus number of moles of B. That's it. And guys, we know mole fraction, sorry guys, sorry, we know mole fraction of A plus mole fraction of B equals to 1. Means in the examination, if they will give the mole fraction of A and they will tell you to find the mole fraction of B, then what we will do? 1 minus mole fraction of A, we will get the mole fraction of B. Now molarity. Molarity is denoted by capital M. Molality is denoted by 2M. So molarity is what the formula of molarity, guys. Formula we know. Number of moles of solute by volume of solution in liter. Volume of solution should be in liter. If suppose volume of solution is given in ml, then what is the formula? Formula, see, it will remain same. Number of moles of solute by volume of solution. If it's given in liter, means we'll use this formula directly. Number of moles of solute by volume of solution in liter. Khalas. But if suppose volume of solution is given in ml, then we will use this formula. Number of moles of solute by volume of solution in ml into 1000. Okay, and guys, see, molarity is a temperature dependent, because the reason behind is volume is a temperature dependent. So molarity is also a temperature dependent. Molality means 2M. So molality formula is what? Number of moles of solute divided by mass of solvent in kg. We will use it. Suppose you have to find the molality and mass of solvent is given in kg, we will use directly this formula. What is the formula? Number of moles of solute by mass of solvent in kg. Khalas. But if suppose mass of solvent is given in gram, then what we will do? Then the molality will be number of moles of solute by mass of solvent in gram and then into 1000. This formula we will use. Okay, guys, see here, this is the volume of solution. Here we will use mass of solvent. Don't take mass of solution and all. Okay, now this is a note, guys. Remember the thing, drugs are, these are the drugs, cisplatin and taxol, where they will be used, which are effective in cancer therapy. Another drug, AZT, azidothymidine, is used for helping AIDS patient. Remember this drug's name, in the examination they can ask. Now guys, this is the end. Hold your breath for PYQs plus HOTS. Okay, see, HOTS means, not that one. This is a high order thinking skill questions. Oh bhaiya, if you understand, guys, please comment understand, okay, in the comment box.